This lesson is over factoring using the greatest common factor and factoring trinomials. So it's just the basics of factoring. So first off, what is a factor? So a factor of a number is one that divides evenly. Now I think this is, I think that's a confusing definition, and I'm the one who wrote it. I think it's way easier to look at as an example. So 8 is a factor of 48, and the reason is because if you take 48 divided by 8, it equals 6, which is a whole number. It doesn't matter that it's 6, it's the fact that it's not a decimal, it's not a fraction. So 48 divided by 6 is also a whole number, so 6 is a factor. 48 divided by 2 is also a whole number, so 2 is a factor, so on and so forth. The greatest common factor, excuse me, between two numbers is the biggest factor that they both share. So if you look at all the factors of 64 and all the factors of 48, the biggest one that they both have is 8. So it's not 2. 2 is a factor of both of them, but it's got to be the biggest one, and that's one of the things we're going to be looking for today. Now this next one, I'm going to be a bad teacher. I'm going to tell you what to do, and I'm not going to really explain why. And the main reason is because when I try to explain why, maybe I'm just not good at this, which could be, but I think it confuses students more than it helps. So when you're looking at variables, your lowest exponent is the greatest common factor. So between x to the 4th and x to the 6th, x to the 4th is the greatest common factor because that's the smallest exponent. So we'll talk a little more about that later, but that's the easiest way to look at this for now. Just do that, get in the habit of it, and then later on I think it'll make sense when we talk about it. So let's do these first couple problems. So the way we're going to do these is we're going to look at the numbers first. So the 4, the 6, and the -8. They have a common factor of 2. It can be 4 because 6 divided by 4 is a decimal. It can't be 8 because 4 divided by 8 and 6 divided by 8 is a decimal. So it's got to be 2. And then your variables, it's always your lowest exponent. So that's got to be x squared. So what do we have left? Well, from here, we're actually dividing each of those by 2x squared, but I think the variable is a little bit hard. So 4 divided by 2 is okay. That's 2. But then the way I do the variables is I have 3 x's, and I took 2 of them out when I factored, so I have 1 left. The next one, I have positive 6 divided by 2 is positive 3. I had 2 x's, I took both of them out, so it just stays 3. And the last one, negative 8 divided by 2 is negative 4. I had 5 x's, I took 2 of them out, so I have 3 of them left. Now, one thing you can do if you want to check your work, you can work backwards, because factoring is literally the opposite of when you multiply with distribution. So it's almost like undistributing something. And so to work backwards, to check your work, if you just distribute this one to all of yours, you should get this as your answer. So let's look at number 2. Between the 6 and the 15, I can take out a 3. And the lowest exponent is an x with no exponent. So 6 divided by 3 is 2. I had 2 x's, I took 1 out, so I still have 1 left. Negative 15 divided by 3 is negative 5. I had 1 of the x's, but I took it out, so I don't have any x's left. That is your answer. And that's this one's a little bit easier to see. 3x times 2x is 6x squared, and 3x times negative 5 is negative 15x. Next one, number 3, between the 20 and the 35, I can take out a 5. Now, 35 does not have any x's with it, so we can't take any x's out. Because if we did, how would we take any away from 35 if it doesn't have it? So, 20 divided by 5 is 4, but the x to the third stays. We didn't take any x's out. 35 divided by 5 is 7. Obviously, there's no x's in that one. That's why we couldn't take any. So, go ahead, hit pause, and do these on your own. And hit play so you can see the answer. So this one, I take out a 3 and then an x. So 3 divided by 3 is 1. If you want to put it there, you can. You don't have to put it there because we have 2 x's and took 1 out. We have an x there. So we don't have to put the 1 because we have an x there. But if both the 3 and the x were taken out, then you need to put a 1 in there to kind of hold a spot. We'll talk about that later as well. Negative 12 divided by 3 is negative 4. I had 1 x and I took it out. Over here, the greatest common factor is 4, x to the third. So 16 divided by 4 is 4. I had 5 x's, I took 3 of them out. Negative 8 divided by 4 is negative 2. I had 4 x's, I took all of them out. I'm sorry, I took 3 of them out. Said the wrong thing, and I wrote the right thing. 12 divided by 4 is 3, and I had 3 x's, I took all of them out, so that is all I have left. Next one is factoring with trinomials. Now, first off, the difference. Trinomials have 3 terms, so already this one we couldn't use, this one we know we're not going to use that method. And this one does have 3 terms, but notice the exponents are kind of, we have big ones, a 5, a 4, a 3. This only works if you have x squared, then an x, and then no variable. So there are several different ways to do this. There's even different ways to do it this method. I use the same method as you guys did in Algebra 1, at least I think so. I set it up a little bit differently using this x, but I think it's a good way to stay organized. If you do it a different way, that's fine, as long as you show me your work. I want you to see that you're thinking of things and doing things correctly. And if you do it differently and I like that method better, maybe I'll ask you about it. But definitely share your work. The other tip I have with this, make sure you keep track of your negatives. I personally think the hardest part of factoring is keeping track of negatives and positives, and when you multiply negatives and when you add negatives, and I think that's confusing. Also, normally speaking, we have these 4 steps in solving these, but that is when you have a number in front. Now, if you have a number in front or if you have a 1 in front, you do them the same way. You still follow these steps, but if you have a 1 in front or if you don't have a number at all, that number is called a leading coefficient. If you don't have a leading coefficient, you'd be able to take some shortcuts with this. So normally when I teach this, I actually teach where there's a leading coefficient first, because that's the problem. The problem is if you don't have a leading coefficient, you get in the habit of taking those shortcuts, and then when you do have a number in front, you accidentally take those shortcuts when you shouldn't. So I usually teach you the longer way to do it first. That way, hopefully that is ingrained in your brain. The thing is, we aren't going to actually go over this again until like chapter 4 maybe, or 5 even. So I'm not going to bother going over the harder one. I'm going to show you the easier ones first, and then we will learn that later. But that's why you're going to hear me say the first number times the last number, for instance. Our first number is always going to be 1. So technically, it's just the last number for what we're doing today. But a lot of people get in the habit of they just put their last number up here. And they so then when they get to the ones that have a number in front, they put the last number in there and they get it wrong. So you'll always hear me say you take your first number times your last number, because I want to drill it in your head. So sorry I jumped ahead a little bit. My first step is to make this x. And in the top of the x is always your first number times your last number. Now, just like I said, do not just put your last number there. I know some of you guys are going to do that because when your first number is not there, all you do is put your last number in. But that's a bad habit to get into. And the middle number is your bottom number. So this B is the bottom. Once you have that, this is the hard part. We're looking for 2 numbers that multiply to be whatever your top number is, but then they add up to be whatever your bottom number is. And this is where you really want to make sure you're paying attention to positives and negatives. Once you have those numbers, you're putting them on the left hand and the right hand side. It doesn't matter which is which. Now this tip we'll talk about a little bit later, but again, it has to do with positives and negatives. Then step 3, once you have those 2 numbers here, you're going to plug those into your formula. Now, here's the other shortcut if there's not a number in front. If there's a number in front, once you have those numbers plugged in, you have to divide by that number in front. But if the number in front is a 1, if you divide by 1, it doesn't change anything. So if you're over 1, it doesn't do anything. So once you have those 2 numbers, you can put them in there, and then you can also skip step 4. So that's where it's a shortcut. You only do about half of step 3, and then you can skip step 4. So we'll talk about that a little bit later. But let's go ahead and do these steps with number 6. So with number 6, in my x, 1 times 12 goes in the top. So again, I'm writing that out just because I don't want you to forget. So that's why 12 is up there. It's not because it's the last number. It's the last times the first number. And it goes in the bottom. I would prefer, I know some of you guys can do this without showing this little X, but I'd prefer you show it so I can kind of see at least that you, I guess I should say you should either show it so I know that you're at least thinking through things and not copying people. Unless you're doing a completely different method, then as long as you show your work with that method, that's the main thing. However, the next thing, if you do not want to show this, you do not have to. There are some problems that, me personally, I would do it. There's some problems I wouldn't. Some problems I'd only do half of it. But this next step is, now I'm looking for, step 2, Numbers that multiply to be 12 that add up to be 8. Some of you guys know that it's going to be 2 and 6 right off the top of your head. Others of you guys are going to have to think about it. And when I was in high school, I would always not, for whatever reason, I'd have a brain fart and I would get anxious or whatever it is, and I would never think of the two numbers that I need. So what I started doing is I started doing this bracket. I put my number on top, and I'm just going to list all the pairs that multiply to be 12. So 1 and 12, and I just go in order. So I started 1, so I go to 2, 2 and 6. Then I go to 3, 3 and 4. Then I go to 4. Well, I don't need to go to 4 because I already have 4 listed on the right, so I'm done now. That's my whole list. You don't have to try 5, because if 5 would have worked, it'd already be on our list by now. So those are the only 3 pairs that multiply to be 12. Now all I have to do is go through and see which ones add up to be 8. It's that 2 and 6, so 2 and 6. Now the reason I really like this X is because I also want you to do double check. Every time you do this, double check. Positive 2 times positive 6 is 12. Positive 2 plus 6 is 8. Once you have that, you end up getting, you write down your X plus 2 and X plus 6. Again, technically, this should be over your leading coefficient. But since ours is just 1, we can go ahead and skip that step. And again, I know some of you guys do not have to write this part down. That's fine. But for me, it's really nice because you won't ever forget it because you go in a methodical approach and you make sure you try everything. So the next one, the top number is 1 times 60, your first number times your last. Bottom number is negative 16. So factors of 60, we have 1 and 60. Use a calculator if you need to. Four, if you don't know, always double check. Don't ever assume. So that's 15. 4 times 15. 5 should be something. 60 divided by 5 is 12. 6 and 10. And then 7 doesn't work. 8 doesn't work. So we're back to 10. So you don't have to try anymore because we got to our 10. So now this is one's a little bit more tricky, and this is what I was actually doing in step 2 when I said that hint we'll skip over for now. This is that hint. If you look, none of these add up to be negative 16. These add up to be positive 16, but not negative, and you have to be particular with positives and negatives. So the good news is, if this ever happens, if you're that close, all you have to do is change the number or change the sign with both numbers. We're going to do the same thing in number 9 when we get there. So change negative 6, change positives to negative 6, change positive 10 to negative 10. Now all of a sudden, those do add up to be negative 16. But this is where you can double check. Do they multiply to be positive 60? Well, yeah, they do. Do they add up to be negative 16? There you go. So my answer is x minus 6, x minus 10. Same thing with this next one. This one's a little bit different. So 1 times negative 90 goes on top, 1 in the bottom. So now the difference is now I'm looking for factors of negative 90. The other two, the factors that I was listing are positive. All you have to do, though, is make your left-hand side negative. It doesn't matter which one you make negative, as long as it's not both. I just always start with my left. So negative 1 and 90, negative 2 and 45, negative 3 and 30, negative 4 doesn't work, 5 is 18, 6 is 15, 7 doesn't work, so we don't write that down. 8 doesn't work, we don't write that down. 9 works, and 10 works, but we're back to 10. So now which one of these add up to be positive? 1, negative 9, and 10. Now you might say, well, Mr. Stephan, you just randomly, arbitrarily put the negative with the left-hand side, so how do you know it's going to work every time? We'll talk about that in number 9 over here, but I put it on the left-hand side. It worked for this one. So sometimes it works, sometimes it won't. We will talk about how to solve that problem if it doesn't work. So the next one, number 9, one we've all been waiting for. And again, this one's done a little bit like number 7. Let me erase some of this. So 1 times negative 33 goes on top, negative 8 goes on bottom. So factors of negative 33 that add up to be negative 8. So again, I put the negatives to the left, negative 1, 33. 2 doesn't work, negative 3 and 11. Not to skip over, but 4 doesn't work, 5, 6, 7, 8, 9 doesn't work, 10 doesn't work, 11 does work, so we're back here. So we can finish, we're not plugging anyone's in. But again, which one are going to be adding up to be negative 8? Well, these two are close, but they have to be positive, not negative. So you need to flip both of their signs. So this one turns into a positive, this one turns into a negative. So to finish this out, we have x plus 3 and x minus 11. Oh, forgot my favorite part. Make sure you double check. Positive 3 times negative 11 is negative 33. Positive 3 minus 11 or plus negative 11 is negative 8. Make sure you're double checking that stuff. Last but not least, I'm going to do these quick, but I would encourage you to pause the video first and then check your answers. So negative 48 is on top, 2 is on bottom. Factors of negative 48. Negative 1 and 48, negative 2, 24, negative 3 and 16, I think. Always want to double check. Yep, 16. 4 and 12. 5 doesn't work, 6 doesn't work, 6 and 8, or 6 does work, sorry. 7 doesn't work, but we're back to 8, so we're good. Which one of those add up to be positive? 2, negative 6 and 8. So x minus 8, x plus 8. I got too excited with the parentheses. And again, it's always good to double check. Negative 6 times positive 8 is negative 48. Negative 6 plus 8 is 2. Last but not least, factors of 26 that add up to be negative 15. Oops, sorry. 1 and 26. 2 and 13. 3 doesn't work. 4 doesn't work. 5 doesn't work. 6. I think that's it. This is the one we're looking at, but it's negative 15, so we have to add negatives as well. Switch both their signs. Oops. So those add up to be negative 15. So we have x minus 2 and x minus 13. If you have any questions, make sure you don't hesitate to ask. Get ready for that test.